Hello students, welcome back to our channel Diksha Karnataka. So as you know, organic chemistry has a very vast syllabus which includes a lot of name reactions. So in this video, I'll be discussing some very important name reactions for your KCET 2024. So these name reactions are those from where most of the questions are asked. So it's like before starting this video, I want you to all keep your notebook and write down the name of these reactions and prepare them. Okay, so let us start with this first name reaction, that is aldol condensation. It is a very important reaction and many one questions you will get from this topic. Okay, so first of all, whenever you are writing now, you should like three important things you have to remember for every name reaction. First is what is the reactant, okay, next is what is the reagent, okay, and then what is the product. Whenever you revise also, like suppose aldol condensation is there, you should revise what is the reactant, reagent and product. So when you write, you need not write this sentence for note making. For note making, you have to only write aldol condensation, reactant, okay, then reagent and then product. Okay, these three things, if you make a note of all the important, some around 20-22 reactions are there, and then you have to write this reaction also. Okay, so you will make a name of the reaction, these 3 points, and then this reaction. Okay, that is how you are going to start this whole name reaction series. So coming to first aldol condensation, here you have to order the reactants 2 carbonyl moieties. Okay, so this can be any aldehydes, it can be 2 aldehydes, okay, or it can be 2 ketones, okay, or it can be aldehyde plus ketone, anything, okay. This can happen. Another condition here is we should have one alpha hydrogen. That also you mentioned here, if any special condition is required. So presence of alpha hydrogen is required. In presence of what is the reagent now? So reactants are 2 carbonyl moieties, reagent is dilute NaOH, and then what is the product formed? The product formed is beta hydroxyaldehyde or beta hydroxyketone. Okay. Now after this, so I'll be explaining this reaction now. If you have, see how to write the product easily. Okay, so if you have this one RCOH, okay, RCOR, and another is RCOH, okay. Now this is R1, R2 and R3. Now you have to see this alpha carbon should have one hydrogen. Now this carbon should be connected to this carbon, okay. The alpha carbon of one compound is connected with the carbon of the other compound. Now this one will go here and this will become OH. So what is my structure now? R1COH, okay, R1COH, here we have R2, R2 is connected, here we have R3 and COH. Now if we produce heat, there will be dehydration and we will get alpha beta hydroxy aldehydes or ketones. Okay, so I hope this reaction, I will not be reading the whole statement, I'll be telling you the reactants, reagents, products and the mechanism if it is important. Okay, so aldol condensation, very important. Learn this trick, how to write the product, and these 3 things you mentioned, then you can just write down an example. Now going to the next question, carbylamine reaction. So what is this importance of this reaction? It is used as a test for primary amines. Okay, only primary amines will show this reaction. Again, we will be seeing the 3 important categories. First is your reactant. So the reactant is a primary amine. Okay, so this is my reactant. Then what is the reagent for this one? So when primary amines react with CHCl3 in presence of KOH, they give you isocyanides. Okay, that is carbylamine reaction. So CHCl3, chloroform and base are the reagents, okay, and isocyanide is the products. So please write in this session, give the heading carbylamine reaction, then 3 important points, reactant, reagent, product, and then you can write down the reaction. One important point about this is it is a test for primary amines and this one produces a foul smell. Okay, clear? Now going to the next. Cannizzaro reaction, again very important reaction. Cannizzaro reaction is a chemical reaction that involves a base-induced disproportionation reaction. So here what is the key word? It is a disproportionation reaction of 2 molecules of a non-enolizable aldehyde. What is the meaning of this non-enolizable aldehyde? Means it has absence of alpha hydrogen, okay, to yield a carboxylic acid and a primary alcohol. So what is my reactant in this case? We'll write again 3 points. Reactant, you have to write aldehydes without alpha hydrogen. Okay, this is my reactant. Then reagent is your, it's not mentioned here, you can write down concentrated alkali medium. Okay, you can take NaOH, KOH. So reagent is concentrated NaOH. Okay, then product will be carboxylic acid plus primary alcohol. Okay, now you can see this example here. We have taken benzaldehyde, right? This is benzaldehyde. This carbon is alpha carbon. Sorry, this carbon is alpha carbon. Here there is no alpha hydrogen. So this compound can undergo Cannizzaro reaction. Now this one will form, one compound is your oxidized product, another will be a reduced product. So this one will be getting converted to acid, that is oxidized product. This one will be getting converted to alcohol, that is your reduced product, right? So this is also very important name reaction. Now let us go to the fourth one, Clemmensen reduction, again very important one. So the Clemmensen reduction is a reaction that is used to reduce aldehydes or ketones. So what is my reactant here? Aldehydes or ketones. First point, reactant, aldehydes or ketones. Two alkanes. So products is alkanes. And what is the reagent here? Hydrochloric acid and zinc amalgam. Okay. So I don't think nothing to explain here. You have a aldehyde or a ketone group. When you treat with zinc amalgam and HCl, this gets converted, reduced to give you 2H and the compound becomes one alkane. So again 3 points you write down, and these three reactant, reagent and product. So now let us go to the fifth reaction, Etard reaction, again very important one. Okay, so Etard reaction is a chemical reaction that involves the direct oxidation of aromatic or heterocyclic bound methyl group. Okay, so we should have a compound, aromatic compound with a methyl group. Okay, that is the reactant. Okay, now what does it do? It changes this compound to aldehyde, and what is the reagent here? Chromyl chloride. Okay, again 3 points you will write. Reactant is, you can just write down toluene, that will be easy. Reagent is CrO2Cl2, product is aldehyde or benzaldehyde. Okay, very important. Next, Finkelstein reaction, important reaction from haloalkanes chapter. Treatment of primary alkyl halides, okay, with an alkali metal, for example KFKI, leads to the replacement of hydrogen via an SN2 reaction. So you can write down here the reactant. Reactant is RCl or RBr. Okay, product is RI. Product is RI, that is for iodoalkanes, and the reagents used are Ki in presence of acid, right? So very simple one. So mechanisms are not important. You must remember the reagent, reactant and product. Okay, that's why I'm going in this way. Mechanisms here, SN2 mechanism you can know, but it's not required for the exam point of view. Now coming to the next one, Friedel-Crafts alkylation reaction. So this is also very common reaction. What is the reactant here? Aromatic compounds are the reactant. Then what is the product? Alkyl group getting attached. What is the reagent? In presence of anhydrous aluminium chloride. Okay, so you can see here, if you have any benzene group and you can take any RX, for example CH3Cl, right, in presence of FeCl3, or you can also take AlCl3, any Lewis acid, then this CH3 will get attached on this carbon. So this is my, again CH3 will get toluene, right? So alkylation part. Now here one more reaction I'll add, Friedel-Crafts acylation. The same thing will happen if you take here another acylation group, that is CH3COCl. Then in the product we will get COCH3. Okay, done. Okay, so 7 reactions are completed. Next one, Gabriel Phthalimide reaction. This is very important. Here what is the chemical reaction that transforms the primary alkyl halides into primary amines? Okay, so this one, understand, we have primary alkyl halides getting converted to primary amines in the presence of phthalimide. Okay, so here first of all, just you can see this reaction little in detail. This is a structure called as phthalimide. Okay, when you take KOH, it is a base. What it will do? It will abstract this H and we will get N minus and K plus. Now our reagent is ready. Rx is the reactant. So R will bound here and X will be taken away by K. So we will get this NR product. Okay, now to this NR product, if you hydrolyze it, it will break here and we will get RNH2. Okay. So here one more condition is there that you have to remember. This method can only be used for the preparation of primary amines. Okay. Even you cannot prepare aniline with this method. Aniline cannot be prepared using this method. Okay. So next is Gattermann reaction, again an important name reaction. So here the reactants are benzene disonium chloride. So if you write reactant is benzene disonium chloride. Okay. And then for reagent is copper powder in presence of corresponding halogen acid. Suppose you want to prepare chlorobenzene, then you have to take copper with HCl. If you want to prepare bromobenzene, then copper with HBr. Okay. So that is why it is a corresponding halogen acid you have to take. So reagent is, you can just write on copper with HX. Okay. And then product is haloarenes or halobenzenes also you can write on. Right. So you can see here this is benzene disonium chloride N2 plus and Cl minus. Then we have copper plus HCl. So this Cl will be replaced with this one. Okay. So next Gattermann-Koch reaction. This reaction is there in the preparation of benzaldehyde part. So here what is the reagent? First is reagent is benzene. Okay. Reagent is reactant is benzene. Then reactant we have COHCl in presence of AlCl3. Okay. So this one will create this benzaldehyde as the major product. Okay. So this is no other conditions are to be remembered. So first you have to remember benzene is the reactant, anhydrous aluminium chloride, then carbon monoxide in acidic medium, these are reagents, and benzaldehyde is the product. So you can only remember carbon monoxide, that is also okay. You can do with this much. Okay. Now coming to next question, Reimer-Tiemann reaction, another important name reaction. So in this what happens, the reactant is phenol. First reactant is phenol. Then we have reagent. Reagent is important, CHCl3 in presence of KOH or NaOH you can take. Okay. And the product formed here is, we will get OHCHO. This benzaldehyde formylation takes place. Okay. So Reimer-Tiemann reaction is the chemical reaction that is used for orthoformylation of phenols. Formylation is adding a formaldehyde group in the presence of CHCl3 and KOH. Okay. Now here one more thing you have to remember, that is often asked, what is the intermediate formed in this reaction? Then it is dichlorocarbene. Okay. This intermediate is formed. Sometimes we can get a question from this part also. So the intermediate formed in this reaction is called as dichlorocarbene. Okay. Next reaction is Rosenmund reaction, another important one. So here again what is the reagent? Reactant is acyl chloride. Okay. Acyl chloride. So here we have RCOCl, and reagent is hydrogen palladium barium sulfate. So very simple reaction, just remove the chlorine and replace it with hydrogen, right? So it is a preparation method for aldehydes. So we can check here, acyl chloride is the reactant, aldehyde is the product, palladium barium sulfate, hydrogen, okay, in presence of hydrogen is your reagent. So next one, Sandmeyer reaction is very similar to your Gattermann reaction. So Sandmeyer reaction is a chemical reaction used for the synthesis of aryl halides. Gattermann is also used in that case. So from diazonium salts using copper salt. So there is a difference here. In case of Gattermann reaction, we used copper with HX. Okay. And in case of Sandmeyer reaction, you can use directly CuX. Suppose you want to replace it with chlorine, you can use CuCl2. You want to replace with bromine, it will become CuBr2. Okay. So that is the difference here. So reactant is benzene disonium chloride. Then we have CuX based on which halogen you want to add, and then we have the product here. Okay. Haloarenes are the product. Next, okay, Stefan reaction. This is important one, because amines chapter, this is one of the major methods of preparation for this one. So we have first reactant is your nitrile group. Okay, reactant is nitrile group. Reagent is tin chloride in acidic medium. Okay, then if you do further hydrolysis, we will get aldehyde. So major product that you have to remember is the main product formed here is aldehyde from nitriles. Okay. Now, so you can see here, this is the nitrile part. Okay, then when you do this SNH2HCl, it get reduced, then hydrolysis will give you aldehyde. Okay, next, Swarts reaction. This is Finkelstein and Swarts reaction, both are important reactions from haloalkanes chapter. So Swarts reaction is used for preparation of fluoroalkanes, right? Fluoroalkanes. So first of all, alkyl chlorides or alkyl bromides should be the reactant. The reagent can be AgF, HgF, any metal fluorides, and the product formed will be alkyl fluorides. Okay, so you can see CH3Br in presence of AgF. CH3Br in presence of AgF will give you CH3F plus AgBr. So this Br is replaced with this fluorine. Okay. Next, Williamson ether synthesis, very important reaction. In ethers, we have two important concepts. One is Williamson ether synthesis, another is cleavage of ethers. So in this, what happens? One is your alkoxide ion. So there are two reactants. One is alkoxide ion and another is alkyl haloalkane. Okay, you can take any haloalkane. So here the condition that has to be remembered is this haloalkane should be a primary one. Okay, the reaction will not occur if you take any secondary or tertiary haloalkanes. That has to be primary, and then we have displacement reaction and we get ether as the major product. Okay, so what should be there? Primary alkyl halides and alkoxide are the two reactants to give you ethers. The mechanism of the reaction is SN2 reaction. Okay, now next, Wolff-Kishner reduction, very important for aldehydes and ketones. So ketones or aldehydes get reduced in presence of hydrogen, that is NH2NH2 in the basic medium. Okay, so reagent is, we have hydrogen, that is NH2NH2 in presence of KOH. Okay, so the point you have to remember is this reaction takes place in basic medium, and then we get the made product formed will be alkane. So as you can see in this example, this is the ketone group or carbonyl group. In presence of hydrogen, two hydrogens are removed and this H get attached in this carbon to give you alkanes. Okay, so this is reduction. We call it reduction because here removal of oxygen and addition of hydrogen takes place. So now next reaction we have is Wurtz reaction. So in Wurtz reaction we have two alkyl chlorides you have to take, and the reagent should be sodium in presence of dry ether to give you RR. Okay, so what is the use of this reaction? This is used to prepare higher alkanes. When suppose you have taken ethane and you want to make it butane, then you can use this Wurtz reaction. So it always gives you a carbon more than the initial reactant. For example, you have CH3Br and you treated it with Na ether. So this part, R part will get doubled. So we will get CH3CH3. Okay. Now suppose you have taken with ethyl bromide, then there are two carbons here. In the product we will get 4 carbons. So whenever there is a conversion of higher alkanes, you can think that Wurtz reaction can be helpful. So another thing that you have to remember is sodium metal has to be used and 2 alkyl halides has to be used. Okay, in Wurtz reaction both the alkyl halides are same. Okay, now we have Wurtz fatigue reaction. This is very similar to the Wurtz reaction, but here you can take one. So here you can take one RX, which is your haloalkane, and another R-X. This one should be haloarine. Okay, that means one aliphatic compound and one aromatic compound you can take. Then this R and R- can combine to give you RR-. Okay, so here it depends on which number of carbons you can take. So you can get any number based on Rx and R-X you have taken. Now again the reagent is same here, sodium metal in presence of dry ether. Okay, so next reaction is HBZ reaction. So this one, in this reaction we have first of all the reactant should be a carboxylic acid group. Okay, one important thing that you have to remember for this, it should have alpha hydrogen. Okay, so what this reaction does, it replaces the alpha hydrogen with a halogen group. Okay, so if there is no alpha hydrogen, the reaction will not happen. For example, if we have this compound CH3, CCH3, Suppose we have this acid. This is alpha carbon. It doesn't have any alpha hydrogens. Then we cannot do HVZ reaction in this case. Okay. So there has to be at least one hydrogen, one alpha hydrogen for the reaction to happen. Now in this case we can get this reaction. So what basically happens in this reaction, as you can see, this is the functional group. This is the alpha carbon. It has 2 hydrogens. Now the reagent is bromine in presence of PBr3. So bromine will be added with one of the H. So here one hydrogen is replaced with bromine. So what are the reactants here? So reactants are carboxylic acid, reagent is Br2 PBr3, and the product is your alpha halo carboxylic acid. Okay, so this is also important reaction. Next we have Hofmann bromamide degradation, very important reaction for the preparation of amines. Okay, and this reaction is also only for the preparation of primary amines. There is another important point with this reaction is the reactant and the product. Suppose in the reactant there are 5 carbons, in the product there will be 4 carbons. 1 carbon gets reduced. Okay, so what is the reactant here? We have to take any amide group. Okay, amide group is treated in presence of X2, any base and water, and then if you heat it, this part, okay, this part is removed and we will get RNH2. Okay, so primary amines alone can be synthesized from this method. So we can just see this statement here. Amide reacts with bromine and an aqueous solution of sodium hydroxide, that is Br2 and NaOH, which produces primary amine. Okay, so this is a degradation reaction as the primary amine in the product has 1 carbon lesser than the primary amide. Okay, so that is because this carbon CO group is removed, so 1 carbon less. Okay, now let us see the next reaction, Kolbes reaction. So this is also important one. We have first of all phenoxide ion is the reactant in which it reacts with carbon dioxide to form orthohydroxybenzoic acid. Okay, so let us see the mechanism here little bit. First of all, phenol is there. When you treat it with NaOH and CO, this ONA is there and then CONA replacement happens. Then if you just do hydrolysis H+, you add OH and COH. Okay, so this compound common name is very popular. Please remember its common name, that is salicylic acid. Okay, fine. So these were some very important name reactions from all the organic chemistry chapters. So as I told you, please remember mechanisms are not important, but you can remember the reagent, reactant and product, okay, for all this. So if you have found this video helpful, please like, share and subscribe our channel. Thank you so much.